the presentation. I'm going to tell Scott when we need to move the slides, but it is really a pleasure to be here with y'all. And so I just wanted to start out with a couple of cartoons because really they show how numbers don't make sense to many children, that children don't see that, you know, 4 can be broken up into different number partners. Next slide. And then also we don't help matters by contriving word problems sometimes that are pretty crazy and kids can't relate to, and they don't make a lot of sense. Okay, so this is an overview of the presentation, and basically it goes from research to practice. I'm going to spend just a little bit of time talking about the long-term consequences of math difficulties, why number sense is important, how number sense is related to math achievement. Then I'll go over an operational definition of number sense that guides screening of number sense, as well as some number sense interventions that we've developed in our lab. So those final 2 bullets are what we're going to spend most of the time on in this presentation. Next slide. Okay, first, the math problem. As you guys all know, poor achievement in math is widespread with very serious educational and vocational consequences. Students who don't develop foundational math in elementary and middle school are less likely to graduate from college than our higher achieving students. And most disturbingly, large discrepancies or disparities exist between middle and low income children before they enter school at about 5 years of age. So it really is striking that we can see these differences so early. Oh, next slide. I'm trying to control it myself. Why focus on number sense? Well, first, kindergarten number sense uniquely predicts broad math achievement throughout the elementary grades, even when we adjust for reading, age, other math skills, and general cognitive abilities. And there are large individual differences, as I mentioned, that exist before children enter kindergarten around 5 years of age, and these differences do continue into 1st grade. So children who leave kindergarten with poorly developed number sense may never catch up to their grade level peers unless they get intensive help. And most important is studies have shown that these early number competencies are malleable and they can be taught to most children. So it isn't something either you know or you don't know. And even interventions work for those who are at high risk for later math difficulties. So in terms of some math barriers, most children with severe math difficulties, or sometimes referred to as dyscalculia, have particular problems with symbolic systems of number. And so this kind of weak number sense knowledge can be reflected later in poorly developed counting procedures, very slow fact retrieval, and inaccurate computation, all things that are signature characteristics of early math difficulties. And it's important to keep in mind that it's difficult to memorize math facts without understanding how numbers relate to each other, without having that kind of sense of number relations. And so accurate counting also helps children learn about number relations and make strong connections between an arithmetic problem and a solution, which thus reduces the need for rote memorization. And of course, ineffective instruction that doesn't focus on number sense can be a barrier for many children with learning differences. Now, we're focusing on number sense here, but it's important to keep in mind that math content in early childhood from pre-K to 1st grade does cover multiple topics. But still, I'm arguing that number knowledge is of primary importance, because if you can see in these two examples of geometry and measurement, children still have to have some basic number skills to think about how many sides are in a shape, or how to measure the length of something like a pencil or a ruler. This is a graph that we developed a number of years ago to show that there are 3 distinct number sense growth classes in kindergarten. And so you can see that in the red line, those kids, they start out high and they stay high. And then there's another group of children who, in the green line, start out kindergarten pretty low, but then through typical instruction, they grow and they get close to the higher achieving children by the end of kindergarten. But then there's this group of children that we're very concerned about, and it's not an insignificant number of children that start out low and they make very little progress throughout kindergarten. And these children had not, at that time, had not received any kind of special interventions. And another thing that we did find that poor math achievement in the later grades is mediated by weaknesses in number sense. In other words, that, well, yes, these low-income learners are likely to have difficulties, but the idea is if we can boost their number sense, then we can make them more available for learning conventional math in the later grades. Okay, so for the purpose of screening and intervention, we operationalize number sense as knowledge of number relations, and number operations. And I'm going to explain each one of those because they do motivate our assessment and intervention development. So first, in terms of number, and I'll show you some examples of these ideas after this slide. Verbal subitizing is the ability to recognize very small quantities immediately without counting. So if you see 2, you just know 2 or 3. Then with larger numbers and quantities, counting is the key basis for extending understanding beyond these very small numbers. Children has to grasp that one-to-one correspondence, that each item is counted only once. The count words have to be used in a consistent order. And then, of course, a key insight is that the final number in any count indicates how many items are in the set, often referred to as the cardinality principle. And by understanding that principle, it allows you to count on from different quantities and really think about later calculation principles. And then also children begin to, they recognize and name written numbers, and then early values of place value, early understandings of place value concepts. So this is an example of some counting skills. So the first is the stable order. So it would be, you would count 1, 2, 3, 4, 5, not in a different order. One-to-one correspondence. So you have these dots. And the child can really count them any way they want as long as they keep the stable order, and you'll always see that there are 5 if you count them all in a stable order. And then finally, cardinality. If you say how many circles, the child might say there are 5 circles. Or you might say, give me 5, or something like that. So they show that they understand that the final count word is the number of items in the set. Then with respect to number relations, children also start to learn that they can compare the magnitudes of of 2 numbers. So they might see that 5 is greater than 4, or 5 is 1 more than 4. And this helps them construct a linear representation of numerical magnitude such that each number is exactly 1 more than the previous number in the count, no matter how high or low you're counting. And this is also known as the n+1 principle, that n+1 is always the next number in the sequence. And then finally, number operations is really built on knowledge of number and number relations, ideas about cardinality in counting and the n+1 principle. Children gradually learn that numbers can be broken down into smaller sets of numbers, which is a key insight that goes a little bit beyond regular subitizing, but they can see that 6 can be broken down into 1 and 5 or 2 and 4, sometimes referred to as number partners. And then, of course, finally is the ability to transform sets through addition and subtraction. And young children can actually do this conceptually before they can solve a calculation algorithm. And the next slide shows you an example. So this is a task we developed a long time ago to get at what we call nonverbal calculation. So the child would be shown 3 dots. And then they're covered with a box with an opening in the side. And then the child sees 2 more dots. And those dots are slid under the box. And now you have to remember that there were 5 hiding under the box, and we would ask the child how many dots are there, or sometimes we would give them dots and ask them to put out the number of dots that were hiding under the box to make the task completely nonverbal. Okay. So then, early screening, that kind of gets, so using that model of number relations and number operations, we want to start thinking about early screening, which is a crucial first step for catching children who are at risk for falling behind, and then making decisions about who might need further intervention, and of course who would then need more involved diagnostic testing, perhaps to identify some kind of learning disability or dyscalculia. Now, there are a number of early numeracy measures out there. I know people asked about measures that are available for screening number difficulties. The most common ones that are out there, at least in the United States, are the quick 1-minute fluency assessments, like the Aspens, the Ames Web, or now Acadian's Math, and they go from kindergarten through the elementary grades. But they do have a universal screening, but they really are very quick progress monitoring tools. And the 1-minute assessments, have limitations when you're dealing with young children and you're trying to figure out how they're thinking about problems. And then there are other screeners out there, but they tend to be available just for 1 grade or age level. And then also we do have the comprehensive diagnostic achievement instruments such as the Key Math or the test of early mathematics ability that are commonly used, but they take probably about an hour to administer. So, in response to these issues, the need for number sense, as well as the need for having a useful diagnostic tool, we developed the Sense based on a grant we received from the U.S. Department of Education with the primary purpose for identifying learners who might need extra support in number sense knowledge. And so the Sense has 3 separate forms at pre-K, kindergarten, and 1st grade, which to our knowledge, it's the only screener or the first screener that is vertically scaled to span the early childhood period when crucial number foundations are built and consolidated. And so what the vertical scaling does is it allows it, even though you have a given form that you give at a particular grade, you don't have to give the whole test to everybody. And but it allows to compare the child's performance at the different grades on the same scale. So like you might determine risk factor, the child was at risk at the beginning of pre-K, then in K you could also determine if he's still at risk or no longer at risk. And the number sense, oops, can you just go back for a second? The number sense screener is an extension, the sense is an extension of our earlier number sense screener, which is a research edition, which you can get now. It's published by Brooks. And the new screener that's more extended is based on that particular instrument. Okay. So the sense provides more information than quick timed assessments. And what it does is it balances an in-depth assessment of number sense knowledge with the practical limits on administration time in the classroom. So it takes less time than a comprehensive instrument, a diagnostic instrument that are used primarily by educational diagnosticians and school psychologists, but it does give you more information than these quick 1-minute timed assessments. And the sense is explicitly built on a conceptual framework. First, as I mentioned, it's built on our operational definition of number sense. Also, the idea that number sense can be measured along a developmental continuum, that we see these skills, these number sense skills, developing at the different ages with different types of activities. Of course, number sense uniquely predicts future math success. Core deficiencies in number sense underlie many math disabilities, and deficiencies in number sense can be reliably identified early on. And as I mentioned, number sense is malleable, and targeted help in number sense leads to improved math achievement in school. And that's so important because, if we can help these children through intensive intervention, it's also important to try to catch the children who need this type of help early on. So this is just, I'm not going to go into a lot of the psychometric development of the sense, but we did select our items based on extensive psychometric analyses. We standardized it on a large group of diverse children, and the measure is found to have high reliability and validity, and we focus group tested it with teachers to make sure that it would be a useful type of screener that they would want to use in their classes. And it's just showing that the correlation coefficients that the test does have, if you give the test to a child once and give it to them again 2 weeks later, they essentially will get the same score. And also the items within the test are highly correlated with each other, resulting in high internal consistency and high test-retest reliability. So this is the structure of the sense with sample items, and I'm going to show you the examples of these items. So don't worry if you don't get it all, but this is just kind of a summary table showing across the rows that how we looked at the different areas of number sense and at the different grade levels and the different kind of concepts we were trying to get at, like counting, number comparisons, and then composition and decomposition of numbers. So this, so what I'm going to do is run you through some examples for number relations and number operations at each of the 3 grade levels: pre-K, kindergarten, and first grade. So with object counting, it's simply the children are shown picture and we say, here are some marbles. I want you to count each marble, touch each marble as you count, which is one-to-one correspondence. And then also ask them how many there are in the set. And then maybe also say, give me 3. And so that is the give-in test also to assess cardinality. And then in kindergarten, the counting gets a little more sophisticated, not just general counting to 10 or even up to 100, but now we have, I'm going to start counting by tens, and when I stop, you keep going. I'll let you know when you've gone high enough. Okay, let's try it, 10, 20, you keep going. Okay. And then with the next one, first grade, we're going to play a counting game. I'll start counting, and when I stop, you keep going, 143, 144, and then you say go ahead and have the child count up several items. And then, of course, by kindergarten and first grade, we get into some simple place value items where the child has to point to the number that shows how many blocks there are. So the number tasks that I just showed you, the counting tasks, are pretty straightforward. Now we're getting into number relations and really getting kids to think of linear representations of number on a number list. So here the child would see a number chart with 1 and 4 filled in, and the examiner would say, look at this number chart, here is 1 and here is 4, and I'm going to give you a number card and I want you to put it where it goes. So put the 3 card where it goes on the number chart. Okay, and then in kindergarten, it gets a little less concrete, I should say. And here now the child is actually looking at a number line from 0 to 10, and you say, look at this number line. This line starts at 0 and stops at 10. These marks show where the numbers should go in the line. Point to where the number 8 goes in the number line. And so the child has to point where the arrow is. And then in first grade, this is another example of a harder linear representation of number problem. And here now we say the number line starts at 10 and ends at 50. And you say, look at the number line, this line starts at 10 and goes up to 50. These marks show where the numbers should go, counting by tens. So the assessor points to the 40 and they say, and then the assessor would say, what number goes here on this number line? Okay, and then finally, number operations. Here now with the young children, we get into we look at it through non-symbolic composition and decomposition of number. And this task is even a little easier than the one I showed you before, the non-verbal calculation item, which we also have on the sets. But you would say, here is a set of 5 dots. We are going to use these tokens to make the same numbers here. So I'm going to put out these tokens. Now, if you finish making a set of 5 tokens. So then they have to they're actually given the materials and the manipulatives. And then you put them up there so the child makes the same quantity. Okay, now we're getting more into symbolic composition and decomposition of number. So you would say, look at my block with the number 5 on it. Now look at these domino blocks and point to the domino block that has the same total number as my block. So they would have to see, I mean, they don't have to calculate 2 and 3 is 5, but they have to see that 5 is made up of 2 and 3 rather than 3 and 1 or 2 and 2. And while they're doing this, you can observe the strategies that they might use to get the solution. So then in first grade, it becomes more symbolic with the composition and decomposition of numbers. Now we have mixed representations. So you might say, look at my block with the number 10 on it. Now look at these domino blocks and point to the domino block that has the same total number as my block. And so the child there has to, the quantity is a little bit larger, but they have to think about merging the symbolic with the non-symbolic. So we can kind of go through this quickly, but we do have an online scoring portal that allows teachers to enter the names of their students. The sense designed right now is actually, it's not given on the computer, it's given one-to-one with the teacher with actual manipulatives. And in our focus group, we did find that the teachers preferred that. I don't know how you all might feel about that, but right now it is a physical test, but you can put the scores into the online scoring portal by child. And this is just an example in kindergarten. And then it will spit out for you the results, and the ones in red are showing that the child is deemed at risk based on a cutoff score that we have psychometrically determined. And then also you can then look at the child where they perform in the different areas of numbers. So you can kind of determine where they might benefit from targeted intervention, and we are providing recommendations for activities and support based on specific areas of difficulty.